Okay, I will go and choose a test study that a random sample of 55 university students was selected. The study time and exam scores for each participant were recorded. For the calculation to find probability value of the test study is about a random sample of 55 university students was selected and the study time hours per week for each participant were recorded. So to tabulate the probability distribution function, first the study time s is 0 and the value of s equal to 13. So probability 13 equal to 0.2364. Next, the probability of 1 equal to 0.0545 and P2 equal to 0.1273, P3 equal to 0.1636, P4 equal to 0.1455, P5 equal to 0.1091, P6 equal to 0.0545, P7 equal to 0.0182, P8 equal to 0.0364, and P9 equal to 0.0364. And P10 is equal to 0.0182. Next, to tabulate the cumulative distribution function, f0 equal to 0.2364, f1 equal to 0.2909, f2 equal to 0.4182, f3 equal to 0.5818, f4 equal to 0.7273, f5 equal to 0.8364, f6 equal to 0.8909, f7 equal to 0.9091, f8 equal to 0.9455, f9 equal to 0.9819, and f10 equal to 1.0001. So the total cumulative probability is slightly higher, more than 1, due to the round off of the values.
Hi, my name is Masini Salamael. My matrix number is AN210137. For my part is chapter 2, which is calculation to find special probability distribution of the case study for binomial distribution and Poisson distribution. For this question, referring to table case study 2.0, for binomial distribution, the question is, a survey from the university found that 20% of students was very satisfied with their result. If 20 students are selected at random, find the probability that none score less than 50%, exactly 10 score less than 50%, not more than 8 students score 50%, greater than 8 students score 50%, and at least 8 students score 50%. For question A, none score less than 50%, we are using the formula NCR times by P x times Q n minus x. For question 1, the n is 20, the P is 0.2, Q is 0.8, and x equal to 0. For the probability that none score less than 50% equal to 0.0115. For question B, exactly 10 score less than 50%. The answer is 2.031 times 10 to the power of negative 3. For C, not more than 8 students score 50%. The answer is equal to 0.9. For D, greater than 8 students score 50%. The answer is 0.9. For question E, at least 8 students score 50%. The answer is equal to 0.0321. For Poisson distribution, the question is, in the case of student exam score, suppose that the number of students score higher follows a Poisson distribution with a mean of 5. Find the probability that exactly 25 students score higher than 70%, 10 students score higher than 70%, and at least 2 students score higher than 70%. For question A, exactly 25 students score higher than 70%. We use the formula exponent negative x times by x. I'm sorry. The formula is actually exponent negative mu times by mu to the power of x over by x factorial. For question A, exactly 25 students score higher than 70%. The answer is 1.295 times 10 to the power of negative 3. For question B, 10 students score higher than 70%. The answer is 5.191 times 10 to the power of negative 12. And for C, at least 2 students score higher than 70%. The answer is 1. That's all from me. Thank you.
Hi, my name is Renabel Emiliana Raymond. My matrix number is CN210103. So for my part is I'm going to present chapter 3, and I'm going to explain about how calculation of sample distribution. As for our data is for population, so we're going to find out the mean, standard deviation, and variance. So for this population data, the size of population is 55, which means there are 55 students and there are 55 exam score that will be calculated, and the total of exam score is 2,895. As for mean, we're gonna use the total of the x, which is the total of exam scores, and it will be divided by the size of population, which is 55. So the mean that has been calculated is 52.64. As for variance is 614.72, and then the standard deviation that has been calculated is 24.79. So since the size of population is more than 30, so we're going to use the z value data. So we're going to find the z value for sampling distribution. So here's the formula. So from this data, we're going to find the probability of students that get an exam score in between 70 to 90. So next is, this is the probability formula that we're gonna use. The first one on the left side is 70 minus 80 divided by 614.72, which is our variance. And the next one on the right side is 90 minus 80 and divided it by variance. The reason that we minus it 80 is because 80 is in between 70 and 90. So this is the graph that I sketched, and on the left side, the point that I get for the negative value is 0.02, and on the right side is 0.02, which means the data that I get is for this graph is equal. So we're going to use this formula, which is 1 minus 2, and the 2 will be multiplied by the value of the probability, which is 0.02. So using this value, we're going to find it on table of areas intel of the normal distribution. So the value that I get from the table is 0.4920, and after being calculated from that formula, so the value that I get is 0.016 or 1.6, which is I convert it into percentage. From this, I can conclude that there is 1.6% of students that get exam score in between 70 to 90. That's all from me. Thank you.
So for the calculation of estimation or confidence interval for a single mean, the test study is a random sample of 55 university students was selected, and the exam score for each participant was recorded. So from the test study, the population mean is 52.64, and the population standard deviation is 24.57. The number of samples n is 55. For this estimation, we use 95% confidence interval. To construct the 95% confidence interval, alpha equal to 0.05. So to find the value of the right tau and the left tau of 95 centimeter interval, we need to divide it by 2. So alpha, so 0.05 divided by 2 equal to 0.025. So next we find the Z alpha over 2 value by using the percentage point of the normal distribution table. So Z 0.025 equal to 1.96. Next, we use the formula for normative interval for mean population. So S bar plus minus Z alpha over 2 times center variation divided by square root n. So equal to 52.64 plus minus 1.96 times 24.57 divided by square root 55. So equal to 52.64 plus minus 6.49. So at 95% tomato interval, the two mean of exam score is between 46.15% to 59.13%.
Okay, my name is Kathleen Shanti Anambita. Metric number is CN210229. Today I would like to present about chapter 5, which is topic hypothesis testing. What is hypothesis testing? Hypothesis testing is methodological process for determining whether research study findings are consistent with specific idea that pertain to population. To evaluate a hypothesis about populations, hypothesis testing use sample data. The major purpose of hypothesis testing to choose between two competition hypotheses about the value of population parameter and about a population parameter, while a hypothesis test is a rule that specific for which sample value the decision was made. There are two complementary hypotheses in hypothesis testing, which are the null hypothesis and alternative hypothesis. The null hypothesis symbol, which is HO, basically answer is no. There is no effect in the population, while the alternative hypothesis H1 answer yes, there is effect in the population. Step in hypothesis testing is write the original claim and identify whether it's the null hypothesis or alternative hypothesis. For the steps 2, use alternative hypothesis and determine the type of test. Write down all the information from the problem and find the critical value using the table. Step 3 is compute the test statistic. Step 4 is decide whether to reject or not the new hypothesis. For the step 5 is write the conclusion. This is our case study, which is exam score. This is the data, 55 data. The question is, research claim the student who study with time are greater exam score than a student who does not study with time. The mean exam score was 52.64. A sample of 55 university students take this year by research produced a mean exam score of 66.4, with a population standard deviation is 24.79. Using a 0.05 level certificate, test the hypothesis to claim the relationship between study time and exam score. For the solution, step 1, find the HO and HI, which is mean score here is 52.64. As the question given, study with time are greater exam score than a student who does not study with time. So M1, M greater than 52.64. So this is the mean is 1/10. For the step 3, find the information in the question and put that out. For the sample is 55 sample. For the mean is 52.64. And for the standard deviation is 24.79 and alpha we use is 0.01. For the mean exam score is 60.4. For the step 3, find the formula which is Z test or Z for whether it's Z test or ZT. Okay, for this equation we use this formula x bar minus mean equal by standard deviation divide by square root of sample. So just plug in the x, which is 66.4 minus mean is 52.64 divide by 24.79, which is standard deviations, divide square root sample 55. So after calculation, 66.4 minus 52.64, then the answer is 30.76, and for the answer 24.79 divide square 55 sample is 3.3427, and after calculate this the answer is 4.1164. Before that, as we know, we use the alpha 0.01. The alpha 0.01 is using this table percentage point of the normal distributions is 0.01 is 2.32663 for the alpha, which means the result is reject. For step 5 is conclusion. There is not enough evidence to support the claim that the mean of exam score is greater if does not study with time by using a 0.0 level of certificate. Thank you.
My name is Sherlyn Teo Xuening. I will present the 6 regulation slides with given data tables as shown. A sample of 55 university students was selected. Study times as X and exam score is Y. For the questions A is fix at least square lines that will enable us to predict the study times in terms of the relative exam score. First, sum up all study times and get 175. Besides, sum up all the exam score and gets the answers is 2,895. Third and fourth is square roots the study times and exam score X and Y and get the answers is 937 and 185577. Last is sum up X and Y is totals 12385. Using the formulas as shown to calculate the SHY and SHX and gets the answers 3.174 multiples 10 square 3, and the answers is 380.18. Furthermore, just insert the SHS and SYY to get the answers of the slope of the line. Next, to find 26.07 of intercept, just insert the values that have found. The simple linear regressions is 26.07 plus 8.35 multiples a sample's mean. Question B is estimates the study times when the relative exam score is 40%. So the answer is 694. Finds the person's correlations coefficients using the formulas R equals X SSY divides by the SSS multiples SYY, and finally get the answers is 0.89 is less than 1. Last is found the coefficients of determination with correct tables, we found the samples means of y. Our SSE is get 6702.227. And to find the coefficients using the formula r squared equals SYY minus SSE divided by SYY. So the final answer is 79.8%. Thank you.